Welcome to The Explainer. Today we're diving into what could be the next massive leap for AI, agents that don't just talk, but actually act for you online. I mean, what if you never had to book a flight or fill out another tedious form again?
Just think about it for a second. An assistant that doesn't just give you answers, but actually goes out and completes complicated tasks for you right there in your web browser.
You could just say something like, hey, find me the cheapest flight to Paris next month, but the layover has to be under 2 hours. And poof, it just goes and does it, navigating all those confusing travel sites and spitting out the perfect itinerary without you having to click a single thing.
And all that tedious data entry? Gone. The agent would be smart enough to handle every single field, every drop-down menu, every little button, saving you so much time and, let's be honest, frustration.
This right here, this is the dream of what we call Agentic AI. It's a goal-driven system that can actually interact with the digital world to get stuff done for you.
So, unlike a simple chatbot that just spits back information, these agents are built to perform a whole sequence of actions to hit a specific goal. They don't just talk, they do.
But as this dream started getting closer to reality, researchers began noticing something a little strange. The performance of these new agents seemed, well, almost too good to be true. It was like an illusion of progress.
You had these early tests, like one called Web Voyager, showing agents with these incredible success rates, and that set off a big red flag in the research community. I mean, could they really be that good, that fast?
So, to figure out what was really going on, researchers cooked up a deliberately simple agent. And what they found out was pretty eye-opening. Okay, get this. They made a naive search agent that could literally only do one Google search and click one single link. That's it. And that super simple agent was able to solve 51% of the tasks. Half of them. And that just blew the whole thing wide open. It showed the agents weren't really learning how to navigate complex websites. They were just finding a clever backdoor to the answer. It's kind of like a student who just finds the answer key instead of actually learning how to solve the math problems.
And when these agents did fail, they failed in these weirdly human ways. Applying the wrong filters on a shopping site, or, and this is a classic, just forgetting that last crucial step, like clicking submit. Let's zoom in on that first one though, hallucination.
This is just a brilliant illustration of the problem. It's a perfect example of what we call hallucination in AI. The agent says with full confidence, yep, I sorted those job listings for you. But the visual proof, the screenshot, shows it never even touched the sort button. It just made it up.
So all of this revealed a really critical need for a better test, a benchmark that actually mirrors the messy, complicated, unpredictable nature of the real live internet.
And so, a new generation of benchmarks was born, with things like online mind-to-web leading the charge. This thing forces agents to navigate actual, live websites to do multi-step tasks that you or I would actually perform. No more easy shortcuts.
And to get a really clear picture of what's going on, the tasks are broken down by difficulty, basically based on how many steps a person would need to get it done.
Now this is where it gets really interesting. Look at how dramatically the performance drops as the tasks get harder. Even for a powerhouse agent like OpenAI's operator, sure, it nails the simple tasks, but its success rate just plummets when things get even moderately complex.
This shows us that what's called long horizon planning, thinking many steps ahead, is still a massive, massive challenge. It's because every single step introduces a new chance for an error, and those mistakes just pile up, making complex goals incredibly hard to nail down reliably.
Okay, so with a proper challenge in place, a real test, the focus has now shifted to the real work. How do we actually build smarter, more capable agents?
Well, researchers are exploring some really fascinating strategies, and they're drawing inspiration from pretty much everything, from how our own brains work to some really clever computational shortcuts.
So, for example, there's this framework called PAFA that totally moves away from slow, step-by-step thinking. Instead of figuring everything out from scratch every single time, it builds a library of common action recipes that the agent can just pull from instantly. It's way, way more efficient.
Other models are being taught to have something called a world model. This is essentially giving the AI an awareness of cause and effect on the web. It lets them predict the result of a click before they actually make it, which helps them avoid a ton of mistakes. And then
Some agents, like one called Web Expert, are even being designed to mimic human fast and slow thinking, so they can combine these quick, intuitive actions with more careful, deliberate planning. And, maybe most importantly, they can actually learn from their past mistakes.
So, if there's one thing to take away from all this, it's that building a truly general-purpose web agent is a monumental challenge. But it's also, without a doubt, one of the most exciting frontiers in AI research today.
The progress is absolutely undeniable, but so are the hurdles that are still in the way. And that leaves us with a really profound question to think about as we look to the future.